Howdy. Welcome to the AGEC 317 review session for Exam 1. In an ideal world, we would be having this in person, but circumstances being what they are, we're going to have to do this in a review video. So the way this is going to work is I'm going to run through some regressions that are going to be very helpful for you to know on Exam 1. So I'm going to go through pretty quickly in this video, but feel free to pause and catch up. You can follow along with the same exact data set. So the same folder you pulled this review up in, you'll find this Excel sheet called Review Excel. It's just a slightly modified version of the SOTA expenditures data set. So go ahead, and if you don't have that pulled up already, pause the video now and pull that data set up. And so we're just going to be using this data to run through several useful models. So for exam 1, it's cumulative. Modules 1 through 5 are included. However, it's kind of important to realize that module 5 is a culmination of all of the modules that come before. So really, a lot of the material is actually going to come directly from module 5. But module 5 has embedded in it all of the other modules, essentially. So if you're going to focus on one module to study for the exam, I highly recommend you study module 5. Problem set 5 is also going to have a lot of material that's going to be on the exam. So between completing the problem set and studying for and reading over the module 5 material, you should be set. Okay, that said, again, I'm going to go through some pretty key modules. So the first thing, I guess, is to watch the YouTube video also linked in this folder on eCampus that goes through basic multivariate regression. Obviously, that's kind of the starting point. You need to know how to do that, and there's a longer video explaining how to do that in detail. So for here, I'm going to go ahead and just jump into the more advanced model specifications. So let's go ahead and look at the first model. So this document is available to you as well. So we're going to start with this model here, which is SOTA expenditures as a function of income of some individual, their age, and their gender. Okay, so this is a dummy variable regression. Income is a normal quantitative variable measured in US dollars. Age is a normal variable measured in years, and gender is a dummy variable that is, very importantly, equal to 1 if this person is female and equal to 0 if this person is male. Okay, so what this model is going to tell us once we estimate it, we can imagine what this is going to look like for the different genders. And so I'm going to refer you back to the lecture material. This exact model is in the lecture. So we can look at what that model looks like for females and what it looks like for males. And what we see is that for females, there's going to be an intercept here of beta naught plus beta 2. And for males, the intercept is just going to be beta naught. While the partial effect of income is on expenditures is beta 1 for males and beta 1 for females. Okay. So with this dummy variable regression, all we're seeing is just a parallel shift in the curve. And that shift is, the intercept for females, again, is this beta naught plus beta 2, and for males, it's just beta naught. Which means, going back to our model, that beta 2 is, or in this case, slight notation difference here, beta 3 is going to be the difference between the genders in SOTA expenditures. Okay, so for males, the intercept is beta naught. For females, the intercept is beta naught plus beta 3. The difference between those two is just beta 3, which means whatever we get for beta 3, that's going to be the difference in SOTA expenditures between males and females. Okay, so let's go ahead and just run this regression and see what happens. Okay, so we'll go back to our data set here. We have SOTA expenditures, we have gender, we have income, and we have age. Okay, Again, all of the right-hand side variables need to be together in Excel. So I'm going to go ahead and take the gender column. I'm just going to select all the observations here and cut it and paste it in column I. Okay. So now we have all three columns together. We can actually run the regression. So I'm going to go to the data tab up top, data analysis, hit regression. Okay. The Y range is going to be soda expenditures. So select all the observations there. The X range is going to be income, age, and gender. So we're going to select everything there. All right. Include labels, and I'm going to send this to a new worksheet and call it dummy variable. I'll just say DV for short, and hit enter. Okay, so there's our dummy variable regression. We can go ahead and look at the output. We have an adjusted R-squared of 0.668, meaning that income, age, and gender explain almost 67% of the variation in soda expenditures. It's pretty good. The p-value on the f-test is very small, much smaller than our alpha, meaning that the model is jointly significant. Okay, meaning that at least one of these three coefficients here is going to be statistically significant, meaning significantly different from 0. Okay. If we look at the p-value for each of the associated coefficients, we see that for the intercept, which is beta naught, we get a significant coefficient. For beta 1, which is the coefficient on income, significant. For beta 2, significant. And for beta 3, also significant. All these p-values here are much less than 0.05. Okay. Great. That means we can take all these coefficients as given, and we don't have to consider any of these to be 0. We can just take these values as they're estimated here. Okay. And like we said before we ran the regression, this difference here of 175, if we go back to our model, we already said that beta 3 is going to be the difference in soda expenditures. That's going to be the difference in the intercept. And again, the base category here is females. Okay, so what that means is, because this coefficient is negative 175, this means that females on average spend $175 or $176 less on soda than men. Okay. That is holding age and income constant. Okay. Pretty simple model, dummy variable, pretty simple interpretation. Right here it says females are spending $176 less on soda than men. Okay. Okay, so that's the first model, done. The second model is a little bit more complicated. So now we're going to run this regression here, which is, again, soda expenditures as a function of income, age, and now we have these three variables, dummy variables, E1, E2, and E3. So if we go back to our actual data set, we see these variables E1, E2, E3, E4. Okay. If we scroll over just a little bit, we get an explanation of what these variables mean. So E1 is equal to 1 if the highest level of education for that person is less than a high school degree, and then 0 otherwise. E2 is equal to 1 if the highest level of education is a high school degree, 0 otherwise. E3 equal to 1 if the highest level of education is some college, and then A4 is if the highest level of education is a college degree. Okay. So in this data set, we consider these to be exhaustive, so every single person has to fit into one of these categories. Okay. So, for example, this first person here spent $109 on soda, and their highest level of education is E4, which means they have a college degree. Okay. I'm going to jump down here to this row 11. This person here spent $71 on soda, and their highest level of education is E2, which means a high school degree. Okay. Okay. So that's what these mean. So every single person here has to have a 1 in either E1, E2, E3, or E4. Okay. The highest level of education has to be something. So these dummy variables totally capture the education for every single person. And unlike gender, there are multiple categories. So with gender, what we have here is just 1 and 0, male or female. But for the levels of education, you can have a lot more categories. And so we have multiple dummy variables that capture all of the different categories you can have for this variable. Okay. So again, I'm going to refer us back to the original lecture material. So I go through just a little bit of detail why. So if we try to run this model here with all 4 of these dummy variables, that's going to result in a violation of this collinearity assumption. Okay. So this regression, as I've written it here in the lecture, is not possible. I encourage you to go ahead and try to run this model, but you're going to get an error in the regression table. The reason for that is of these 4 variables, one of them is redundant, meaning that if I know your highest level of education is not E1, it's not E2, and it's not E3, then I know your level of education must be E4. Or on the flip side, if I know your level of education is not E2, not E3, and not E4, then I know your level of education has to be E1. Okay, so we have 4 dummy variables, but they're redundant. So when we have dummy variables with multiple categories like this, we have to omit one of the variables. So it doesn't matter which one. We can choose E1, E2, E3, or E4. We omit that variable. We consider that variable to be the base category, and then the coefficients on all of these other variables that are included, those are going to be the difference in that intercept term in relation to the omitted category or the base category. Okay, so that's a lot, but again, the lecture goes into a little bit more detail of how we interpret all of those. So again, I would take a look at that if you haven't already. So what we're going to do here, though, is estimate this model. So soda expenditures as a function of income, age, and then E1, E2, E3. This means that we're omitting E4, which is the highest level of education category. So that's going to be our base category. Okay, so let's run this regression. Okay, we're going to go to pull up Excel. What we need is income and age next to E1, E2, and E3. So we're going to have to do some moving around. You can do this however you'd like. There's a lot of ways to move things around. I'm going to insert a couple of columns here and just move income and age next to the education. Okay. So now we have the model with all the variables we're going to run next to each other. Okay. So now I'm going to go ahead and run the regression, data analysis, regression. The Y range is still soda expenditures. The X range here is now income, age, E1, E2, and E3. Again, we're omitting E4. That's our base category. So select that range, and I'm going to hit labels and then send this to a new worksheet. I'm going to call it dummy variable 2. Okay, and hit OK. And there we go. We have our regression output. We can go ahead and take a look. Okay. So what we see here is the adjusted R squared 0.315, meaning that income, age, and these three education dummy variables explain 32% of the variation in SOTA expenditures. Our F-test here is less than 0.05, meaning that our model is jointly significant, meaning that at least one of these coefficients is significantly different from 0. Okay, that's good. And if we look at the individual p-values, we see that the only p-values that are less than 0.05 are these first three here. So that's the coefficient on the intercept, income, and age. And all of the education dummy variables are not significant. Okay, we can look at the p-value, and all of these are greater than 0.05, meaning that these three coefficients here are insignificant, meaning that we should consider them to be essentially 0. Okay. So even though we see E1, E2, E3 as these numbers here, the way we should read this table is E1 is equal to 0, E2 is equal to 0, E3 is equal to 0. Okay. So what this means is that on average, SOTA expenditures for people with a education less than high school is no different from the base category, E4, which is people with a college degree. Okay, so this coefficient of 0 means that there is no difference between SOTA expenditures between people with a less than high school education and people with a college degree. Okay. Similarly, with E2, people with a high school degree have no significant difference in demand or SOTA expenditures than people with a college degree. And then finally, people with some college experience have no significant difference in SOTA expenditures compared to those with a college degree. Okay, so the interpretation here is the same. It's just the difference compared to the base category, but here education has more categories than gender, which means that we have to include more dummy variables. But all the coefficients are in relation to the omitted category, which is the base category that you leave out. Okay, and that's, of course, all that is holding age and income constant. Okay, great. Okay, and then in the next video, we're going to go ahead and finish these next few models up. So we're going to do a dummy variable with an interaction term and a log-log model, and then finally a quadratic model.